My name is Hugo, and today we're going to be talking about this review on events and how to get started with your Kafka journey on Kubernetes. So let's get a quick review on why event-driven architecture, because it's important to recap that event-driven architecture tries to mirror the real world. For example, if you go to a coffee shop and you order your coffee, you don't get stuck until somebody prepares your coffee and then delivers it to you. Most of the time, you just go into one place, somebody takes your order, and then they send the order back to the barista that is the one that actually prepares your coffee, and then you get called to pick it up. That's a very good use and analogy on how event-driven works. You get into a message, deliver that, and then you wait for you to be called, and if you are interested in that event. So it's a very good way to decouple the runtime and the actual type of technology that you use in your services. That also allows you to scale independently. That means that only the services that are under a heavy workload are the ones that you need to scale, and they can be in different technologies. So that's a very good form of approach to near real-time communication and connectivity in your services, so you don't need to be polling like you do in the traditional synchronous type of communication. So let's go and do a review of what is an event. So an event most of the times represents a change in the state in your system. So something happens in your application or in any single part of your service. And then it's when something needs to be generated as an event, as a message, and be propagated through the system. So every person that is interested, every service that is listening to those events can react and either discard that event or be able to, do some processing for that. And there are different types of consumption patterns for events. So we have been checking the different type of usage for events, and we have come to with these 3 different type of events that we think are the more representative events that are flowing in traditional systems. So the first one is what we call the volatile events. The volatile events are those kind of events that are happening in your system, but you really don't care that much if sometimes you you don't have a consumer that are listening to those events, or if one of those events gets discarded or it's been lost. So you can think about, for example, IoT devices that are sensing the temperature of a room, and you only care about the average temperature for the whole day. So sometimes if you have a device that is sending information every, I don't know, couple of seconds or a couple of minutes, if you lose 1 or 2 of those records, you perhaps don't have any trouble with the calculation of the average temperature of that room. Also, if there's no one listening to that specific event, perhaps it makes no sense to keep them track of those events or store them until somebody picks up that event, because sometimes it could be that the state of the system is not something that you need to review when somebody is able to consume that event. The second type of events are what we call the durable events. And this is the most common type of events that you will find in your system, where you have these events that you need to persist. And you usually associate this with the traditional messaging brokers, where they care and take care of which system or service is connected to the broker and is listening to which messages. So the broker is smart enough to be able to deliver the messages to all the different consumers that are listening to those events, and it's able to keep them in that state until somebody is able to consume them. And then the third type of event is the one that you might be interested if you are playing with Kafka, is the type of events that we call replayable events. So it's kind of a specialization of the durable events, where those events are being stored, but the intelligence to take ownership of the events and decide which consumer needs to get those events are delegated away from the broker into the client. That means that the broker is just enforcing the acknowledge and reception of events and the storage of them. And then the consumers or the clients are the ones that needs to ask the broker for a specific event, most of the time is using offsets to track the position of the message that they need to read. This way, the brokers that implement this type of consumption patterns can store the events for a long period of time, or sometime defined in days or in size. And this allows us to have clients that are able to not only receive those events, even though those events were generated before the consumer was even created, it also allows us to replay events that perhaps needs to be updated, or you need to have a second pass for that information. So these kind of events will shape you the form of the different solutions and implementations that you will require for your system. And that's why we have created this table that will help you to define which kind of consumption pattern do you have and what do you want to implement. So for example, when you're talking about durable events, you will be thinking about traditional messaging infrastructure like GMS brokers. In our case, for example, could be the ActiveMQ broker or the MQ broker, that it's part of this GMS broker tradition, where you can have these kind of implementations. And more of the time, that will be very suitable for durable consumption patterns. And it will be less suitable for replayable events. The second type could be the router for volatile events. If you have volatile events, or you are doing a common query type of events sending to your consumers, then the router based in AMQ interconnect, for example, could be a very good use for those kind of patterns. And because this is a router and not really a broker, there's no ownership of the message, so it cannot store. So if you want to do durable or replayable events using the router, that will not be the best pattern to implement. And then there's the third pattern, that it's the one that implements replayable events, and you can do also durable events that you can implement using Apache Kafka. So there's the difference between the different two technologies on the broker and the router, and the case of Apache Kafka for being able to use those events. As we have mentioned before, if you need to do message filtering, or you do transactions or other kind of manipulation of your individual messages, Kafka will not be a suitable pattern to use in this case of scenarios. Okay, so now we talk a little bit more about running Kafka on Kubernetes. So you have this checked in the previous moments what are the difference between using a traditional GMS broker and when you're using Apache Kafka and different consumption patterns for events. So let's talk about what are the different challenges when running Kafka on Kubernetes. Most of the times, you know, that Kafka has been created in the past, like 2010, and you were able to run that software on traditional virtual machines. But now with microservices and the adoption of distributed pattern, we see that Kafka, it's a very good fit on these type of scenarios. But now we are moving to containers. So we expect also Kafka to be able to be a nice citizen on the Kubernetes and the container world. So what can you do for that? That's why we have AMQ Streams. So AMQ Streams is this implementation to run Kafka on Kubernetes. It's available also on traditional virtual machines, but the main value that you can get for is with the use of that solution on top of Kubernetes. This type of approach for running Kafka on Kubernetes requires two different things. So the first one is be able to have container images. Most of the times when you go to the Apache Kafka project, you will be able to download the zip files, and it will be your task to be able to get those container images, build them, and then get them running. So one of the things that you can get with AMQ Streams, it's being able to get all those images being validated and secured, and being able to validate that they're enterprise ready with Red Hat's support. And then the other second thing, it's actually most important thing that you will need to have on Kubernetes. And those are the Kubernetes operators, or the operator pattern. So for that, through AMQ Streams, we have been working with the upstream Streams community to be able to create all these components on top of the vanilla Apache Kafka to be able to manage all these components on a Kubernetes environment. We know that Kubernetes is super useful when you want to abstract and have this abstraction layer on top of your infrastructure. So you will think about nodes and resources, virtual CPUs and memory assigned to your application, as well as just persistent volumes, and you don't need to actually deal with what type of infrastructure are you running on top. So that will be certainly useful when you are trying to deploy Kafka on top of that. The problem is that you still inherit all the different management tasks that you will need for your Kafka cluster. I mean, you will need to deploy first Zookeeper, then configure your Kafka nodes to start those different Java virtual machines, and then we allow them to connect, and then configure the listeners, and then configure the different properties that you will require for your topics and for your other elements of the Kafka ecosystem. So if you're moving just to containers on plain Kubernetes, that will be not enough. You will still need to be able to manage that. And perhaps not just a stateful container, you will need to do configuration on stateful sets. So that gets a lot of, it becomes a little bit more complex. And you certainly will not want to do any follow-up on those kind of complexities. So what you can do instead is delegate all that complexity into Kubernetes operators. And that's where you can get a lot of value. So in our case, with MQ Streams, you get all these Kubernetes operators to be able to manage not only the Kafka cluster or the Zookeeper cluster, but you also are able to manage all the different elements from the extended Kafka ecosystem. For example, you will be able to manage the Kafka topics, the Kafka users, as well as, for example, Mirror Maker or your HTTP bridge, and you can configure information like, for example, the cruise control balancer. So you want to do balancing of your topics. So it's something that goes beyond the traditional deployment, just using a chart or just deploying the deployment config files. So let's see how this deployment works and how you can delegate the deployment and the configuration of infrastructure as a code. In our first deployment, we just need to deploy the cluster operator. There are several ways to deploy this cluster operator. You can just run the YAML files, or you can use the operator hub to download this operator. When you have this operator running, then this operator, it's a controller that takes ownership of the management of your Kafka resources. And you will certainly most of the times require just one operator for your cluster. And then this operator can monitor different namespaces and manage different Kafka clusters. So one operator can manage different type of Kafka clusters. So now that you have your operator deployed, what you need to define is a custom resource. So the operator uses the different Kubernetes APIs. So you're able to declare just a file called a custom resource that defines the desired state of your Kafka cluster. So in our case, we want to define that we want a certain amount of nodes in our Zookeeper cluster and so many nodes in our Kafka cluster. And then the operator will be able to read that information, get the details, and then start to populate, first deploying the Zookeeper cluster where it creates all the nodes, then deploy all the Kafka clusters, and then at the end, deploy an additional operator. It's an additional controller that will take ownership of things like topics and users. This operator also keeps track of all changes, and if there's any deviation of the configuration, it will update automatically. So for example, if you want to update your version of your Kafka cluster, the operator can also do that. Actually, the MQ Streams operator for Kafka, it's one of the most mature operators that are there already, because it goes all the way to be able to update and upgrade your implementation. And as I mentioned before, this operator not only focuses on deploying the Kafka cluster, but also it's able to deploy other components, as I mentioned, like the bridge or Mirror Maker or the Kafka Connect cluster to configure your connectors. So in this way, we are able to have a more advanced way to manage and deploy Kafka on Kubernetes, so we can benefit of two things that Kubernetes operators offers. So Kubernetes, it's a way to be able to manage an abstraction layer on top of our infrastructure, and then having the Kubernetes operators that allow us to offload all the management requirements and tasks from a human operator into software that allows us to easily interact and have our infrastructure declared as code, and then being able to deploy and manage those objects in our Kubernetes cluster.